Hello, hello, hello. All right, so hello everyone. This is Awais. So today we are gonna basically start with our session for basically Saturday night live. Welcome to my stream. Let's begin. So I originally planned to basically do some very interesting questions about ASNA2, and we may might also look at some questions from IGCSE tonight. So let's check it out. So let's check from one of these workbooks that I have. And by the way, we are gonna start with, let's go down. Let's start with this particular question where it's a very weird one, actually. And it was basically back in those days, they used to give very stupid estimation questions. And this question basically states that you have like the volume you have to estimate in centimeter cube of a head of an adult person. So that's something pretty awesome. Now let's see. So at that time, people were like, what we can do about it. So one thing that I want to basically share with you is basically at that time, people literally were confused that how to, solve this question. So let's suppose somebody's like face is like this. So literally they put a ruler like against their head and they were like, okay, let's measure what would be the, in centimeters, what would be the length, right? So usually when you see this, it comes out around um, 10 to 15 centimeters. And they were like, okay, that's fine. So that means if I can take my head as a sphere, or I could take my head as a square, that would probably work. So a lot of people took it as a square and they were like, okay, if this is 10 centimeters, then this will be 10 centimeters, this will be 10 centimeters, which means that actually the volume is going to be 10 times 10 times 10. So it's going to be around 1,000 meter cube. And this is quite funny, but actually people got it right. A lot of students actually got it right. And it's an old question. But this is an interesting question, thinking that, okay, this is something that work still, and they can still give you very, very weird questions actually. So by the way, if you have any questions, you can also go on Mirha exams, sign up for Saturday Night Live. You can actually join in the session by connecting to the Meet link that's already inserted to join now, and you will be with me. You can ask live questions if you want to. Also, you can post your questions if you want. All right. Then I'm gonna look at one question where basically it's about the you know uh, measurement. Let me just go there, see what we have got there. So let me show you this. Yeah. So generally, I want to basically look at this question, which is a classic question about volume and length, and they want, uncertainty in the radius of the cylinder, which is r. So in this sort of question, if I were you, I would basically look at this as a power and a multiplication question. So what you do is first always check if the units are perfectly similar. So right now we do have all of them in centimeters, and this is also in centimeters, so that's good. So the first thing you should do is find the radius. So make the value, the variable, in fact, that you need the subject. So this is the first thing you should always do. Like we need R in this. So that means I will be writing it as R equals to V over pi L and then under root. Why under root? Because there was a square on it, so I took it there. Now, the next thing you got to do is you have to find the value of this. Naturally, you would want the volume is 15, and then there's pi, and then obviously it's going to be 20. So you could simply use your calculator, take root. I really like this natural display calculators. If you have one, um, that's a little like it helps you a lot. If you even if you don't have it, it's okay. So as you can see, it becomes 4.886, right? And then what you got to do is basically you want something like you have to build the uncertainty. You have to get the absolute uncertainty. So there's a method to this, okay? So when you have the equation built, you can write it like this. You can take fractional uncertainty of R divided by R equals to change the uncertainty of V over V, and then just leave some gap, and then uncertainty of L over L. We're not going to include pi in this, and the reason we don't want to include pi in this is because we don't want this to, because pi doesn't have any specific uncertainties, it's just uncertainty less. When you have a root basically means that it is a power of half. So basically, we're going to multiply half with both terms where the root is, and then start putting the values. Like this is R, and then this is going to be the value that we found out, 4886, and then half. Take the value of V. So uncertainty V is 0.5 divided by 15.0 plus half. The L is going to be 0.1 and 20.0, like that. Now what you do is basically you go to R, and this is going to be delta R. You can use the calculator again. Let's do it here. So write 0.5 times, you can put 0.5 divided by 15, and then obviously this is going to be added with 0.5 times 0.1 divided by 20. Now, as you can see, you get this answer, um, which is 0.01917, and then it gets multiplied with this value. So you can write it as 0.4886, and this is going to be something like, you could say 0.4886, and that comes out to be 0.00936, right? Now, one thing that I want to tell you, let me just move this to this side actually, and I want to basically tell you, whenever you're writing the answers, make sure that the absolute uncertainty that you write is always one significant figure. So if I convert this to one significant figure, it's going to be 0.009. Then the next thing I want to basically show you is that I want to write this answer, which is the actual answer, as same decimal places as uncertainty. So right now I have three decimal places, so I will keep the same decimal places for the answer. I had 0.4886, so up to three decimal places, it will be 4, 8, and 9. Now, this is how the uncertainties are written, and you should follow it if you really want the last mark. Everything else before that obviously has to be correct. Now, if you check the mark scheme for this, so this is basically paper 2 of '07. So let's open it up on probably row of papers. I don't know where that is. Let me find it out, huh? So row of papers, where are you? Interesting. Let's find it here. All right, so we're gonna go to the yearlies and get the mark scheme for, I guess, 2007, which okay, paper 2. Let's download it. So I guess it should be somewhere here. Where are you? Well, that's not fair. I don't know if I opened the right paper or not. Paper 207. Oh, this was October, November. Sorry. I have to go winter paper 2. Right. So in this one, as you can see the answer right here, they have a very different way of solving. They do accept the way we have done it, 0.5 or 1, 15, but they do it separately. And then you see the last answer is the same, one significant figure for the uncertainty, and then you have R as 0.489. So that is pretty good, right? So that's done. Now, these are the one type of question that I wanted to really discuss with you with regards to the uncertainty. But then we can actually talk about the other things like uh, you know, a question that I basically a lot of people find it very difficult, and this is this question, but I want to discuss a different one, and when they give you percentages, right? So let's suppose they have given you an equation as this, which is t equals to root of k r cubed over m, like that, and they want like you to find the um, uncertainty of k, the value of k, and the actual uncertainty as well, the absolute one. So if I were you, I would basically first of all check if all units are SI units or similar units that I need. So they need SI units, so that's fine. And then I would want to basically make k the subject. So I'm going to take square on both sides. So if I take square of the whole equation, this will be t square equals to k r cube over m, like that. Now speaking about that then, you see here we can multiply m on that side. So k will then be equal to t squared times m over r cubed. So this is basically the final form of the equation that we've got to use. So the first thing is you got to find the value of k, put in all the values that you have, like t is 8.64 into 10 raised to power 4 whole square multiplied by mass, which is 6.0 into 10 raised to power 24 divided by, oh wait, yeah, okay, r square, r cube. So 4.23 into 10 raised to power 7 and then cube it off. This way it's going to work like this. Then we're gonna use the calculator again, put it in the right form. 8.64 into 10 raised to power 4. Just make no mistakes while using the calculator. Multiplied by, I guess, 6.0 into 10 raised to power 24 kilograms. And finally put this as 4.23 into 10 raised to power 7, and that's going to be a cube. So this comes out to be, the value of k basically comes out to be as something like, check the details quickly. So 5.918 into 10 raised to power 11. Now what I'm going to do is I want to find the uncertainty of k. I have the equation right here. So what I'm going to do is, let's change the color first. So I'm going to write delta k over k equals to delta, first is t over t, then plus delta m over m, and then we have delta r over r, like that. Suraj, this is the workbook that I'm basically, this is my workbook, but the paper number is right here. This is basically the first AS unit of measurements, right? Physical quantities and measurement. So you can check out this paper, okay? You can open it up and you can access the book on Mirha exams as well. All right. So what you're going to do is then you guys need to put in the values. Now, when you have percentages, consider this your lucky day. Why? Because you don't really need to change anything, right? You don't need to change anything. In fact, you can put the percentages directly. So let me show you. So I'm going to write delta k, and the value of k I just found out was 5.918 into 10 raised to power 11. And then, oh, by the way, t had a square on it. So I'm going to, whatever the power is, you got to multiply the power with a fraction. And then m doesn't have anything. R has 3, so 3 here, right? So that's going to work for you. Now what you do is 2 times, just pick the percentage. So write 0.5%. Then plus m is 2%. So write 2%. No need of changing anything, doing anything. 3 times, this r over r has 1%, so just write 1% like this, right? So what you're going to get at the end is delta k is 5.918 into 10 raised to 11. And when you multiply everything, so you'll see that this is going to be, see, 2 times 0.5 plus 2 plus 3 times 1 is 3. So this is going to come out at 6%. Now I just want to find the value of k. So I'm delta k actually. So I'm going to write 6% multiplies with 5.918 into 10 raised to power 11. So that's what you got to do. So now just multiply 6. You can divide by 100 or use the percentage sign. It's okay. 5.918 into 10 raised to power 11. And you can see basically it's kind of like 3.55 into 10 raised to power 10. Now this is a thing there where I want to warn you, or I want to show you why it is so important. You see, when you're dealing with uncertainties, I have already told you that you have to write this as one significant figure only. So one significant figure means it should be written as 4 into 10 raised to power 10. So I'm going to write 4 into 10 raised to power 10. Now there's no decimal place, but there is a 10 raised to power 10. So I have to convert this because I want to write this in same decimal places. So I have to convert it to 10 raised to power 10, which means it's going to be somewhat like 59.18 into 10 raised to power 10. Obviously, I need to cover it up for no decimal places. So that will be 59 into 10 raised to power 10. So you can write it as 59 into 10 raised to power 10. Make sure that this power and this power is always same in order to get the right answer. Otherwise, you will be pretty much stuck. So you can have a look at it, and if you have any questions, you can post it. That would be pretty good. All right, pretty awesome. All right, good. So now that we've done this question, um, let's check out another uncertainty question and see the variation. So one of these questions that I want to basically focus on is sometimes they are going to give you uh, normal values like absolute uncertainties. Oh my God, that's not fair. So normal values like absolute uncertainties. And then they're also going to give you some other values with percentages. So this is a mixed question, right? So this is the third type of question that you should always, be very, I guess, careful about. So it says in a simple electrical circuit, the current in the resistor is measured. So this is I. The resistor is marked having a value. So this is R. If these values are used to calculate the power dissipated in resistor, what would be the percentage uncertainty in the value obtained? Now, obviously, we have to first remember that power is I square R. This is the formula for power with respect to current and resistance. So that means we are going to then check out how it works out for us. For instance, you see, we want uncertainty only, so we don't need to find the power value. We're going to just write delta P over P, and then the first variable is I, so delta I over I, and the second variable is delta R over R. Then check if there are any powers. Obviously, there's a power on I S squared, so we're going to multiply that right next to I like this. What then we're going to do is we just want percentage uncertainty. So delta P over P, just write like this. 2 times, now I, as you can see, is a normal value. So we're going to write 0.05 divided by 2.50. So this is how it's going to work. Then for R, because it's already in percentage, Hassan, we are practicing uncertainties for AS, that's for Edixel and CIE. Okay. So if you're AS student, you can basically stick. Okay. And you can, access the paper numbers are here. So you can also access and practice with me. So now we have like this situation, and then we have R over R. So you see, R is already in percentage, so you don't need to do anything, just plug in the percentage value, and that is fine, right? Now, I want to convert this whole thing in percentage as well, because this is in fraction. So you just need to multiply 100% here to convert into percentage. That's all you need to do. You take out your calculator and just do 2 times 0.05 divided by 2.50, and then multiply by 100%. So this is going to be 4% plus 2%. And the answer for the percentage uncertainty is going to be 6%. So you just plug in this value. The idea behind this is whenever you have mixed values, you can simply plug that value, which is absolute, and then multiply it with percentage. And other fractions, you can simply add percentages. You don't need to do anything else. Right, kids? So this is how these three uncertainty questions can be handled perfectly. There's no, don't worry about it. So I'm gonna give you kids couple of, I'm gonna give you one more question for practice. Let's do it together. First, I'm gonna give you 2 to 3 minutes. You can try it out, and then I'll solve it. So let's go back. And this is one of my favorite questions where a lot of people get stuck. I don't know why. So this is basically the main question. If you want to access this question, go to this page, please, this paper. This is 970222, May, June 12. And the question number that you got to solve is 1. So try question number 1, and then I'll explain this question to you. By the way, if you guys are still unaware of the platform that we built as Mirror Exams, this is for all those people who have been struggling with going into tuitions, maybe because of transportation, maybe they're slow learners or very fast learners, and they tend to learn on their own. So Mira Exams is a platform where you go and check out the videos, and then you have notes, and then you have quizzes that the AI takes, and then you can attempt worksheets, get a score out of everything, get the explanation. So it's a very handy, affordable um, concept that you can use to enhance your studies on your own. And it's AI guided, so it's always a plus point on that as well. So do sign up if you like that. Also, there's a code that they're giving, which is awesome me. So whenever you're purchasing something, so you can add this code, and that would instantly give you 25% on the total thing. So that's something you can use for your advantage as well. All right. So 1 more minute. All right, kids. So I hope you have tried to attempt it. So let's check the question out. This is a very famous question, and a lot of people have trouble in it. So they've given you an equation, as you can see right here. Vt equals to pi pr raised to power 4 8cl. And what they're saying is you want to find the value of c. Whenever you have certain questions like this, I would recommend to you that you always make the variable that you need to find the subject of the equation. For example, if I want to do this, I'll multiply c on the other side. So this is going to be c equals to pi PR4 divided by then 8 times, and I want to bring the whole thing like this. I'm not gonna, you know, bring t on the numerator. And the reason why I want to do this is because I know from the fact that in the question there is a full value of v over t. So I don't need to get into changing this. It would take so much time, and that's just a very bad, I think, approach to this. So once I have made the equation in terms of c, I'd start putting the values. So it's going to be pi times, so this is c, pi times p is 2.50 into 10 raised to power 3, because it's right here. You should be aware of that. Never ever miss on that. Then you have to multiply r cube. Now, as you can see, r is in millimeters and these values are in meters, so we gotta change that. So that means there's going to be 0.75 into 10 raised to power minus 3 to change it to meter. And then obviously there's a power of 4, so multiply power of 4. Then what you do is, that's done. Then go underneath this, put 8 times, now v over t has a full value of 1.20, and then there's 10 raised to power minus 6. Everything is in SI, so I'm just going to write 10 raised to minus 6. There's no square or anything. And the length is already in meters, so that's pretty good. So write 2.50 as this. Now take out your calculator and try to find this out first. So this is going to be pi times 2.50 into 10 raised to power 3, then multiply by 0.75. Oh, that's not fair. Let's put in brackets. So 0.75 into 10 raised to power minus 3, and then put power 4 on top. That's when you're going to write 8 into 1.20 times 10 raised to power minus 6, and then multiply this with 0.250. So what you're going to get is ultimately 0.001035, right? So this is the value of C. We're going to write it right here. Then what you're going to do is you got to find the uncertainty in C. So that's pretty awesome. So what you're going to do is you're going to use the same formula. I'm going to copy this formula because this is extremely important to look at this formula again and work out your question. So here you have the formula, and I want to find the uncertainty. So let's start writing. I'm going to write delta C over C like this. And then I would want to write pi doesn't have any uncertainty. So delta P over P, and then plus I have delta R over R, then plus, and leave some space in front of it. A doesn't have any uncertainty, but then delta V over T divided by V over T, write it as the whole thing, and then delta L over L. This is going to be good. Now you start adding everything that you found out. Like for delta C, we have found 0.001035. P is basically 0.05 divided by 2.50. Notice I'm not really now taking 10 raised to power 3 in account. The reason for this is that if you take 10 raised to power 3 for this and 10 raised to power 3 for this as well, it's just going to cancel out. So when you're taking fraction of the same value, the power of tens and the units literally don't matter. So then what you're going to do is, obviously, R had a power of 4, so we're going to multiply 4 here. So then you can basically write it as plus 4 times. Now R is 0.01 divided by 0.75. Again, I'm not taking millimeters in account because millimeters on top and the bottom are just going to cancel out. This is what's going to happen. Then we have V over T or V over T, so that's pretty good. So that's 0.01 and 1.20, so 0.01 divided by 1.0. Ignore everything here because it's just going to cancel out. and delta L is 0.001 divided by 0.250. So this is the whole thing. Now this is a big thing, so we have to be very, very careful in finding the value for this. So let's try to do that now. And it's going to be something like 0.05 divided by 2.50 plus 4 into 0.01 divided by 0.75 plus 0.01 divided by 1.20 plus 0.001 divided by 0.250. So this is going to come out as a value of 0.08567. You can actually also find it out and multiply this with 0.001035. So you get basically the value of the uncertainty in C, which is 0.0000886. So if I were you, I would basically write it as something like, I guess, one significant figure is very good. So that's going to round up to 9. So I guess 9 into 10 raised to power 1, 2, 3, 4, 5 minus 5 as my answer. Now what I'm going to do is they ask you to write it in appropriate number of significant figures. Even if you don't write the appropriate number of significant figures here, that's all right. But if you do, it's good. So state the value C and its uncertainty to appropriate number of significant figures. So that's fine. So first of all, I'm going to write it as 9 into 10 raised to power minus 5. And then I know that this is one significant figure, so that's pretty good. And I want to keep the other value that I have, which is 0.001035 for C, to be the same number of power of 10. So 1, 2, 3, 4, 5. So it's going to be 103.5 into 10 raised to power 4. So the best thing is you got to write 104, convert it, and then, oh wait, why did I write it like this? 1, 2, 3, 4, 5. So it's going to be 103.5 into 10 raised to minus 5, and then convert it, so 104 into 10 raised to minus 5, and then it's going to be awesome like this, right? So now it has the same decimal place, and it's basically correct to the same power. Make sure that you always have this. Now let me check if the answers are correct, because sometimes it's pretty tricky. So it's May, June 12, 22. So let's open the row papers. May, June 12, May, June 12, 22. Right. And voila. So as you can see, they have given it in, they have given the same thing, but we have given it as 104 and 9. So that is also fine with the 10 raised to power minus 5. But even if you give it for 10 raised to minus 3, that is all good. So this is how these questions are basically managed. I hope you get the basic idea of how uncertainties can be done. So we have done all three types of questions. Make sure you practice a lot. If you want this workbook for your practice, you can basically go to Mirha exams like this. Let me just open it. And oh, wait, that's not fair. Okay, so you can go to Mirror Exams and then go to Books, and then I have posted my A2, AS, and IGCSE workbooks. You can purchase them off as one time, or if you want to access everything for a monthly subscription, you can go and get the subscription as well. This is the price. You add the code, and hopefully you're gonna get 25%, not hopefully, 100%. And then you have different courses as well that Mirror Exams is offering, like mathematics, biology, chemistry, other stuff. So for today, for AS people, I would highly recommend you can check out this course. It is about 142 hours, which is a lot of stuff in it. The best thing about it is that you can actually start learning. Like you can start from the uh, video and then you can start with notes. Those notes are downloadable. You can get the videos done and then start practicing with quizzes and then start practicing with worksheets as well. So it basically offers the whole course, and I think 142 hours means that you can actually do very nicely in your exams once you basically finish everything because it's a well guided thing. Right. So we are done for today, but before I go, I always recommend you some books to read because I like to read a lot of books. And today's recommendation would be, let me write it here. One moment. So if you get time, uh, maybe after the exams, or maybe if you have time before bed, you can actually go through and read it on different things. But I wanna specifically tell you this amazing book. Those who are interested in, you know, those who feel that they have lost a lot of time and they cannot pick up. So this book is called Buy Back Your Time. It's written by basically Dan Martell. This is basically the author. You can get it on Audible if you want to listen to it, or you can get it on Goodreads. It's also available, I think, on Kindle, so you can also get that. If you're not a fan of reading digital books, you can get this book as a hard copy as well from Amazon or other stuff as well, right? So this is my today's recommendation. If you have any recommendations for me, do let me know. Right. So it was very good seeing you guys today, and hopefully, in the next week we shall meet again on the next Saturday Night Live. And I'm thinking about giving you um, a sort of topic that we're going to do. So most of you who are of different, category students, maybe your IGCSE or A levels, you can join in when a particular topic of yours is being done. So have a nice day then. Have a nice week. See you.